Okay, today our lesson will be about practicing factoring polynomials with higher degree. So we have done the lesson before, but now we need more practice questions. So our first question would be factor fully the following four questions. Factor fully means the remainder must be 0. There should not be any remainder rather than 0. So the first thing we do is, what are the possible factors of this? Negative 12. The possible factors are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. Anything from this can be a factor. It can be x plus 1, x minus 1, x plus 2, x minus 2, and so on. These are the possible factors. So the first thing we do is we just trial and error. We get any number which makes me equal to 0. So I try any one of these. If I try 1 will be 2 minus 1 minus 25 minus 12 is not equal to 0. So x minus 1 is not a factor. So I try f of negative 3. F of negative 3 is, I substitute that negative 3 cubed minus 3 cube square minus 12 times negative 3 minus 12. This equal to 0. Therefore I say x plus 3 is one of the factors, is a factor. Once I find x plus 3 is a factor, I do synthetic division to find the other factors. So synthetic division, I do minus 3 here. I write the coefficients of the polynomial, which are 2, negative 1, negative 25, and negative 12. I write horizontal line here. I bring down the first number 2 times negative 3, negative 6. I add them, negative 7 times negative 3, 21. I add down, negative 4 times negative 3 is positive 12. The last column, if I add, it must give me 0 if this is a factor. Therefore, this is a quotient. The quotient now is, since the original one was x cubed, this will be coefficients of x squared. So 2x squared minus 7x minus 4. So from x squared, x, and then a number. Then I factor this one here. The factors of this will be 2 and 1 by trial and error or by inspection, 1 and negative 4. So negative 8 plus 1 will be negative 7. Therefore, the factors of this will be 2x plus 1 and x. Okay, so this will be 2x plus 1 and x minus 4. This is minus 4. Minus 4. Therefore, the final factors fx is, the first one, I don't forget the first one, which was x plus 3, and then 2x plus 1 and x minus 4. These are the three factors, completely factored polynomial. Okay, this is the first big example here. The next example is 3x cubed plus 5x squared minus 2x. I can see there is a common here. The first thing I check always in factoring is if there is any GCF. There is a GCF in this case. This will be, I take the x out, 3x squared plus 5x minus 2. Then I factor 3x squared plus 5x minus 2. So I find the factors of this, which are 3 times 1, and then 1 times 2 is 2, but this should be negative. Therefore, since this is negative 1 plus 6 will be positive 5. Therefore, complete factoring is x, I don't forget it, 3x minus 1, and x plus 2. Okay, the next one is 2x cubed minus x squared minus 8x plus 4. So the first thing I do in higher degree is I check what are the possible factors here. Possible factors are plus minus 1, plus minus 2, plus minus 4. So I try any one of these, like f1, I try. f1 is not equal to 0, so x minus 1 is not a factor. I try f2. If I substitute 2 here, it gives me 0. Therefore, x minus 2 is a factor. Since x minus 2 is a factor, I do synthetic division here. So my synthetic division will be, I take the 2 vertical line, I write the coefficients here, 2, negative 1, negative 8, positive 4. I bring down 2, 2 times 2 is 4, add 3 times 2, 6, add negative 2, negative 2 times 2 is negative 4. I add the last column, it must be 0 if x minus 2 is a factor. Now, these are, we said, the quotient, these are coefficients. Therefore, it's 2x squared, because the highest one was 3, I take that 2 here, plus 3x minus 2. Then I factor this one here, 1 and 2. This cannot be 2 here, therefore I write 2 and 1. 2 and 2 should not be on the same line because they have a GCF. But this is a negative, therefore this will be negative 1. Negative 1 plus 4 is positive 3. Therefore, the factors of this will be x plus 2 and 2x minus 1. Complete factors of this will be fx. I don't forget the first one, which was x minus 2, x plus 2, and 2x minus 1. This is completely factored. Okay, the last one, it's x cubed, but there are 3 terms, so it is not a trinomial. Attention here, it's not a trinomial even though there are 3 terms. I don't factor it as a trinomial. I factor it as polynomial with a higher degree than 2. So the first thing we do is the factors of 4. The factors of 4 will be plus minus 1, plus minus 2, plus minus 4. I try like f of 1 is not equal to 0. I try f of negative 1 is not equal to 0. I try f of 2, which is equal to 0. Therefore, x minus 2 is a factor. Now, we do synthetic division, which means 2 here, vertical line, horizontal line. I write the coefficients. When I write the coefficients, I have to be attentive if there is a missing degree here. There is no x squared. Therefore, the first one is 1x cubed. There is no x squared, so I have to write 0 coefficient. Then we have minus 2 and minus 4. So this is the only new thing in this lesson here. So we have to have coefficient of 0 because there is no x cubed. So 1 times 2 is 2. I add 4. Negative 2 plus 4 is 2. 2 times 2 is 4. It's 0. Therefore, x squared plus 2x plus 2. I cannot factor this one here. Therefore, if I cannot factor it, my final factors will be fx, x minus 2, and x squared plus 2x plus 2. So these are some examples of factoring with higher degree than 2. If the degree is 2, we use the factoring rules of quadratics.